Hello everyone, today is the last lecture in the series Feature Engineering which we are discussing as a part of content based recommender system. So, we are basically focusing right now on feature selection. In this context, we have seen many methods for feature selection and today we are going to see few more. So, to start with, after last class we were discussing about various information theoretic measures. So, today which is pretty aligned with this probability theory is Gini index. This Gini index is suited for binary ratings, ordinal ratings and ratings which are distributed into small number of intervals. In case you have numeric ratings, you can also discretize and get it intervalized. Now, the ordering among the ratings is ignored in this scheme and each possible value of rating is treated as an instance of a categorical value. Now, this formula is expressed in this way where W represents the feature and within that feature in a particular feature there will be a number of labels. So, basically over all the labels or total number of possible values you will be taking the probability. And it is to be understood that this value will always lie in the range 0 to 1 minus 1 upon t, which is a very small value and smaller the value, greater is the greater it indicates the discriminating power. So, with respect to this response variable like, let us find out the Gini index. So, this Gini index turns out to be 1 minus 9 by 14 and 5 by 14 and taking the square of each of these. Now, where from this value is coming? So, if you look at this variable like, in how many places it is no? In 5 places it is no. So, 5 no and we have 9 yes. So, probability of getting yes is 9 by 14 and probability of getting no is 5 by 14. So, this is yes, this is no. Now, let us try finding out how do we make feature selection. So, now look at this. Our whole aim of talking about this Gini index is finding out what is the best set of features that we should be considering along with this response variable. As I have told you, with this Gini index, we will be making the binary split and find out the best binary split. So, if we are considering this attribute called language, this language has 3 different levels: English, Hindi and other. Now, if we make the split making Hindi and other together and English separately, how do we compute the Gini value for this particular split? Now, how many English are here? There are 4 English, 1, 2, 3 and 4. And out of these 4, we have 2 no's, 1 yes over here and another yes here. So, this part is 2 by 4 for yes, 2 by 4 for no, and total 4 out of this 14 number of data. Now, coming to the other partition which takes together Hindi and others. How many yes? 1, 2, 3, 4, 5, 6, 7. So, 7 yes and 3 no. So, this is taking English in one side and this is taking Hindi and others in other side. So, the total for this particular partition, it turns out to be this value. So, similarly, how many partitions, how many binary partitions you can make? Taking Hindi others, English, 2 partitions, this is one and English other, then taking Hindi, English together and others is another. So, similarly, many partitions we can make, 3C2 number of combinations. So, for all combinations we find and the best split we consider. Similarly, for other attributes also we find out the best split. Now, this Gini value, wherever this Gini value is lowest, we choose it as the first feature to be considered along with this response variable. Then the next best with the next the value which is just above the lowest, that we choose. So, that is how we select. Let us say we have to select only 3 features, then top lower 3 will be selecting. Next one is chi-square statistics. This chi-square statistics can be computed by treating the co-occurrence between the feature and a class by making a contingency table. Now, this chi-square statistic measures the normalized deviation between observed and expected value across the cells in this contingency table. Larger the chi-square value, the more likely the variables are related. Hence, one of them can be dropped. So, basically for categorical variables, we will be able to now find out the correlation in some sense. Now, if the attribute is independent of the class attribute, that is low chi-square value, it may be dropped. This is the formula, and now we will see how to realize this formula. Look at this. Suppose our example has total 1500 data points. Of course, now in the small part that I have shown, we have only 14, but assume that there are total 15, and out of that, taking the variable award and finding its chi-square contingency table with respect to the response variable like, whether the person likes that movie or not, like can take value yes and no, award can take value yes and no. So, how many total yes? This many number of, this is the actual observation, and you take the row sum and you take the column sum here. This is the row sum 250, 200, 450. Similarly, column sum 250, 50, 300. So, that is how you take the total across rows and columns of the actual observation. Then this actual observation gives this value O. Now, what is this expected observation? Expected observation you will be getting by calculating, by looking at this sum and calculating the probabilities. Now, if we have total 1500 observations and 300 are like where like is equal to yes, the probability of getting this is 1 by 5. So, similarly, probability of getting no is 4 by 5. Now, look at this 1 by 5, 4 by 5, it becoming probability is 1. Similarly, column wise also you take 450 by 450, how do you get 250 and 200, 450, 450, this is 3 by 10 and this is 7 by 10. So, now to find out the expected value, assuming that their joint probability will consider. So, 1 by 5 which is coming from here, 1 by 5 and 3 by 10, 3 by 10 is coming from here, 3 by 10. So, this 1 by 5 and 3 by 10 multiplied together with 15 will give us the expected value. So, this expected value, actual value minus expected value square divided by the expected value, and this is summed over all the fields, all the cells in this contingency table. Now, here we have only binary variables. So, therefore, we have total 4 number of cells, but it is not limited to only binary variables. We can have more number of values. For example, in case of director there were 3 director, in case of language there were 3 options. So, in that case it can be if we are computing between these two, then it will be a 3 cross 3 situation. So, now once we find it out chi-square value, then we look for the best attributes which, if an attribute is independent of the class, chi-square value is going to be low. So, it may be dropped. So, with high chi-square value, for whichever attribute, for each of the attribute we will be making one such table, and for whichsoever attribute these values are very high. So, which means it in turn it says that there is a good relationship between this particular variable, particular feature and the class variable, we choose that. So, next one is your wrapper based approach. These wrapper based approaches are widely adopted in the sense this particular while all others are kind of heuristics, here you actually integrate this approach with the algorithm, with the learning algorithm that you are using. So, what do? You first choose the learning algorithm. So, learning algorithm or the classification algorithm in our case becomes the input to this wrapper class. Then what you do? You try taking subset of features and use it along with the class variable in the learning algorithm. So, basically you consider all combination of the features, taking 1 at a time, 2 at a time, 3 at a time and so on. So, if you have total n number of features, then NC1, then plus NC2 plus NC3. So, this way you continue. So, which means it is becoming computationally very heavy, and once you continue, how do you measure? There has to be some kind of metric using which you can decide which set of features can give you the best value. So, now this can happen. This computational complexity can be managed in 2 ways: forward subset selection and backward elimination. In case of forward selection, you start with an empty set. Let us say you have some features f1, f2 up to fp number of features. So, you start with an empty set. This is the total feature, and out of that you will be moving few to this. This will be finally build your model. This you will be finally using build your model. Now, what you do? First make this set empty, then one of these you choose. So, while choosing one of this, you can choose anyone, but typically if you would like to have some kind of prior knowledge on this, probably out of this you will be choosing the one which is highly correlated with another, so that the other one can be dropped automatically. So, let us say you choose some Fi and you have your response variable. Okay. So, with respect to each of these, when you did with respect to your criteria, you got the best combination with Fi and R. So, you decide on this. Now, how many are remaining here? Here you have total p minus 1 number of remaining. So, with Fi keeping, so rest p minus 1 you choose, let us say you now choose Fj. So, with all the j for 1 to p minus 1, you will be now finding, taking these two together and finding and building the model using R as the response variable. Now, you will be getting certain accuracy, or R square in case of regression, you will be getting some such of sort of accuracy criteria, or you can go for cross validation. So, somehow you will be that metric you will try to find out with respect to each one. So, then what happens? You have found out the best combination and you have put it here. So, how many remains here? Now, p minus 2. So, out of p minus 2, now let us say choose some Fk. So, the k can take this p minus 2 values, and with respect to R you find out the model. I mean the model whatever you have used with respect to R as the response variable, you run the model, find out let us say some accuracy measure. Now, that accuracy measure, to whichsoever Fk that accuracy measure is the best, choose that and you continue till the desired number of features are selected. Suppose you decide to keep 3 features. So, now at here itself you stop. In case of backward elimination, just the opposite happen. You take the full set of features and selectively eliminate, keep on eliminating. Eliminate one, test, eliminate second one, test. So, that for first elimination with each individual p you have tested p features. For second elimination, once you eliminate one, for the second elimination p minus 1 remains, third elimination p minus 3 remains, and so on. So, you continue like this. A very well known wrapper based approach is your stepwise regression. Regression is something which we have already discussed in our earlier lecture when we are trying to introduce these concepts on machine learning. So, here also if you choose that your in the wrapper based approach your method is regression, then what you perform for this process of wrapper based approach is called stepwise regression. So, in stepwise regression, as we have discussed, first you have to choose from the p number of predictors or the features. Now, whichever gives you the best value, in the next time you take for the 2 combinations. So, this can again happen. It is one wrapper based approach. So, there can be forward selection or backward elimination. So, in case of forward stepwise selection, what you do? For take all the p features. Now, consider this has to be done in an iterative manner. So, out of all the taking all the variables in the first iteration, you build the model, then check for the value where the highest, the value of highest R square or smallest RSS, or there can be other criteria. What are these criteria? We are going to see shortly. Now, this will be first done with k for k equal for one variable, then with that you will be adding two variables, a second variable, to that you will be adding third variable, and so on. So, if you continue like this, taking one feature, then two features, then three features, and so on, you will have many models, okay, and precisely p number of models. And now, with respect to certain validation criteria like this CP, AIC, BIC or adjusted R square or cross validation method, you decide which is the best subset. So, in backward elimination, again you start from p features, then take p minus 1, last one feature. So, start from the entire set, keep on reducing. So, assessing the accuracy of the model, we can use many metrics. Specifically, this we are talking about regression models, and kind of metric that you decide with other models as the input to this wrapper class can be may be different. So, here in this case we can have R square or adjusted R square, then you can have a residual sum of square. You can have certain criteria with certain penalty. So, this you already are aware of. This we discussed probably at the time of talking about the regression. So, R square is computed in this way, and the value of this total sum of squares is this, where this y cap is the average value of all the y, and in case of residual sum of square, this y I hat is the predicted value. This is the average value of the training set, this is the predicted value. So, now we can think of adding some penalty as well. For example, here some penalty term is added, here some penalty is added, here also some penalty is added. So, there are three criteria: Mallows CP, Akaike information criteria or AIC, or Bayesian information criteria or BIC. So, all these three methods, they have certain penalty term. In this penalty term, D is the total number of predictors considered out of P, and this sigma square cap is the estimated variance of error. Typically, it is determined from the full model, but usually it is assumed certain value and is given as input. So, giving these inputs, you find out these values. So, lower this value, better is your model. Lower this value, better is your model. But in this case, higher the value, better is the model. So, which means using them, you can always test with different sets of features how these criteria are changing, and you stop when you get the best such criteria among all the models. Okay. So, with this we stop, and these are our references. For Gini index, we have considered this. For stepwise regression, we have followed this, and this is our overall reference. These are our conclusions. In this lecture, we saw few new approaches for feature selection. Gini index, chi-square statistics are two of them, which are again kind of heuristics, but in wrapper based approach, you actually use the models as one of the input. So, with respect to the model that you are finally going to use, you select the features in an iterative manner. Both Gini index and chi-square statistics suits to binary ratings, ordinal ratings, and ratings which are distributed into small number of intervals, and we can, if in case of continuous, we have to discretize the values. The basic strategy in wrapper based model is to iteratively refine a current set of features by successively adding features to it. Thank you.